Welcome to This Explainer. You know, if you work in tech, you've probably felt the ground shifting beneath your feet lately. We are literally moving from an era where humans sit there and type commands into a terminal to an era where machines just manage themselves. So today, we're unpacking a massive paradigm shift directly from our source material to look at exactly how AI agents are fundamentally rewriting the rules of Linux server management.
Right off the bat, let's dive into this highly provocative question that is currently on the mind of pretty much every single system administrator and DevOps engineer out there. In the future, will Linux servers no longer be managed by engineers? I know, it sounds a bit like science fiction, but as we parse through the source material today, it's absolutely fascinating to see that this future is already arriving. We aren't just talking about simple code generation anymore. We are talking about full autonomous infrastructure control.
Here's our roadmap for today. Section 1. What is an AI agent? Section 2. AI's automated operations. Section 3. Managing huge Linux clusters. Section 4. The fatal risk of root. And finally, Section 5. Future AI operations architecture. All right, let's kick things off with Section 1. What is an AI agent? To really understand where we're going, we first need to clear up a massive misconception about what we mean by AI in this context. Because when most of us hear AI, we immediately picture a chat window, right? But we aren't talking about a traditional chatbot that simply spits out text telling you how to fix a broken Apache server. We are talking about an AI agent. If you tell an AI agent, hey, find the anomaly in the Linux host and fix Apache, it doesn't just give you a to-do list. It autonomously connects to the server, executes the tasks, issues the bash commands, and modifies the infrastructure itself. It's kind of like the difference between asking for a recipe and having a master chef just cook the meal for you. Now, what's really wild here is the sheer variety of ways this AI sysadmin can grab the wheel. It's using the exact same entry points a human would. The AI agent gains Linux control by establishing a standard SSH connection, maybe running SSH admin at server 01, or by hooking directly into your automation tools like Ansible and SaltStack. It interfaces with the Kubernetes API, the Docker API, or your Cloud API. It is sitting at the exact same control panel you are. Moving right along to Section 2, AI's automated operations. Let's look at a concrete example of how this autonomous execution actually plays out in the real world when something goes wrong. Imagine an Nginx server crashes because a port address is already in use. Usually, a human gets a PagerDuty alert, logs in, and starts poking around. But the AI, it follows these exact logical steps instantly. It SSHs into the server. It runs standard commands like top, freem, and dffh to collect system info. It runs system control status, nginx, and sees the crash. It actively hunts down the conflicting port by running ss-lntp, kills the rogue process, restarts nginx, and actually, this is the best part. It runs a curl test on localhost to verify the recovery was successful. It finds it, fixes it, and verifies it. Zero human intervention required. So, the absolutely crucial point here is that AI can natively understand and correlate massive amounts of log data far, far faster than any engineer ever could. We've all been there, right? Bleary-eyed at 2 a.m., manually reading through /var/log/syslog or offlogs, just trying to piece together a timeline. But present-day AI agents, they instantly perform log correlation, pattern analysis, threat hunting, and root cause analysis across thousands of lines of text in milliseconds. Let's apply this directly to security. Say the AI detects a flood of failed password for root messages. It doesn't just send a Slack alert to a sleepy engineer, it instantly identifies it as an SSH brute force attack, analyzes the attack IP and the frequency, and then autonomously executes the fix on the spot. It writes firewall rules to drop the IP using IP tables, or it instantly updates your fail-to-ban configuration. It's defending the server at literally machine speed. Which brings us to Section 3, managing huge Linux clusters. Because fixing a single server or blocking one IP is really just the tip of the iceberg. Let's zoom out and see how this builds into managing massive, complex ecosystems. These agents are entirely capable of managing entire clusters simultaneously. We're talking fleets of Kubernetes nodes, Docker hosts, VMware virtual machines, and bare metal servers all at once. Because the AI is interfacing through APIs, it executes auto-scaling, load balancing, patching, and complex rollbacks across diverse environments. It has a god's eye view of the whole shebang. Just think about what happens right now when a Kubernetes pod crashes. It's usually a frantic scramble to pull container logs and figure out why. In this new paradigm, the AI analyzes the pod event automatically. If it diagnoses a memory leak, it doesn't just restart the dying pod. It proactively scales out the resources, rebuilds the pod, and then directly modifies the underlying YAML configuration file to ensure it has the memory limits it needs moving forward. It actually learns and adapts the infrastructure code on the fly. No way a human's doing that in 5 seconds. Okay, but here's where things get intense. Section 4, the fatal risk of root. As we hand over the keys to the kingdom to achieve all this incredible automation, we introduce a terrifying new liability. Think about it. To do its job, the AI agent needs high-level privileges. It holds the master keys, it needs root access, it holds all your vital SSH keys, it has Kubernetes admin rights, and top-tier cloud API tokens. To be a super admin, it has to have super privileges. And that makes the AI agent the absolute ultimate target for any malicious hacker. If an attacker actually manages to compromise the AI agent itself, the consequences are, well, they're catastrophic. The source material points out that this introduces an entirely new era of AI-powered attacks. The future cybersecurity battlefield isn't going to be human hackers typing against human defenders. It will be AI versus AI, machines battling machines at speeds we literally can't comprehend. Just think about the damage potential here. A compromised, rogue AI agent can autonomously move laterally across your network in fractions of a second. It can seamlessly disable antivirus protocols, systematically delete its own security logs to cover its tracks, encrypt your data for ransom, or just execute commands to destroy your entire infrastructure from the inside out. By the time a human security analyst even realizes the network is under siege, the damage is already done. So how do we survive this? Let's look at Section 5, Future AI Operations Architecture. Given both the incredible autonomous power and the frankly massive risks involved, where does that leave you, the human IT professional? Are sysadmins going extinct? The answer is no, for sure not. But the role is fundamentally evolving. The past role was all about manually typing commands, grupping through logs, and manually restarting services at 3 a.m. The future role? It's higher level. You will be managing the AI agents. You'll be designing the complex automation workflows they follow, validating their decisions, and most importantly, strictly controlling and auditing their permissions. Basically, you stop being the mechanic and you start managing the automated factory. To support this safely, enterprises are building these really robust, multi-layered AI Linux operations platforms. It's not just a script anymore, it's a full architecture. At the base, you have your monitoring and logs, your Prometheus, Grafana, and ELK stack. Then, the AI layer sits on top of that, utilizing LLMs, retrieval-augmented generation, and agent frameworks to actually process that data. The AI then feeds its decisions down to the automation layer, tools like Ansible, Terraform, and Kubernetes operators to execute the changes. But wrapping all of this is an absolutely vital security layer, utilizing tools like Falco and eBPF to monitor the AI's behavior in real time, ensuring it doesn't go rogue. It's how you build a truly autonomous, self-healing infrastructure. As our entire IT world enters this incredibly fast-paced new era, the source material leaves us with this critical, sobering thought to ponder. The real danger has never been the AI itself. It is an AI with root access. When the AI starts to autonomously judge, execute, and attack, the game changes forever. So, as you look at your own infrastructure today, the ultimate question isn't whether AI will manage your servers, it's how will you secure your ultimate administrator. Thank you for joining me on this explainer. I hope this helped map out the exciting and admittedly slightly terrifying road ahead.